we, in the last lecture, we looked at in great detail and depth the whole filter number one, where we said that under the filter number one, what is first looked at is the invention that we have done, whether that invention is considered as an invention within the meaning of the Patent Act. It may be an invention otherwise, but does the Patent Act recognize that as an invention? We said that there are certain criteria. We went through all that criteria from A to Q one by one, and we said if the invention falls within that purview, then it will fall and get stuck in filter number one. It won't proceed, then they won't even look at it further. That is what we talked about last time. Then we said, then if it comes out of filter number one, whatever has come out of filter number one will go into filter number two. And that's where we stopped here last time, where we said when these inventions are put through filter number two, that filter number two has three considerations. One consideration is called novelty. One consideration is called inventive step. And the third consideration is called whether the invention is capable of industrial application. Does it have any application? Does it have any use? So those three criteria are to be satisfied together. If any one criteria is not satisfied, then you are not supposed to get the patent. So today we will concentrate on these. Before we go through, in the filter number one, also there is an additional factor which we have not considered. That's why I showed you this particular filter this time again. So apart from the listing of all this, there is one more which is very relevant to DAE. What is relevant to DAE? There it says if there is any invention that you have done, you file a patent in India if that invention is related to Atomic Energy Act. The definition of atomic energy as per Atomic Energy Act. Then that invention also will not be allowed to be patented in India. So that's the additional factor which you in DAE must keep in mind. So suppose I come with a very novel way of chilling or cooling the reactor. I may not get a patent for that because that particular thing, if I say it is using heavy water for the purposes of doing this in nuclear reactor, it will say, oh, that's related to atomic energy, therefore we will not give you a patent. Whereas, if you develop that cooling system and say that this is a proper heat exchanger and can do the heat exchange between a hot source and a cold source, this, that, you may get a patent. But if somebody uses it for atomic energy, you will not be able to stop the person. Clear? So that is something that you have to remember, that atomic energy related patents, okay, you won't get in India. That is something which is you have to remember, right? So if it is not related to atomic energy as per the Act, Atomic Energy Act, then it will go through if you satisfy the conditions of novelty, inventive step, and capable of industrial application. So having said that, now I will go quickly. I'm avoiding what we have done in the last time. We went through each one of this. So I come straight to the point of the filter number 2. As we said, in filter number 2, filter number 2 is called novelty. Novelty in the Patent Act means that your invention is new. Now you will say the fact that I did something, I created something which was not there before, that itself is new, therefore it is an invention. Then what is this extra thing that the invention has to be new? Is the question that you have to look at. Now, the way we look at it from the patent point of view, just from the patent point of view, the patent says not novel, not novel, if all the essential features of the inventions are, sorry, it is, if it is novel, is your invention novel, then the criteria for that is all the essential features of your invention must not be available in one single public source of information or in any one single document anywhere in the world. The essential features, not all features, but the essential features of your invention. If one single source or if it found in one single document, then it is said that your invention is not novel. Which means that, let us say that if I create a chair with 4 legs and one handle, and if there is there are chairs with 5 legs, there are chairs with 4 legs and 2 handles, but not one handle. So you may say, oh, in one document it tells you about 4 chairs without handle, and it talks about in another document, a chair with, let us say, 3 legs and one handle. Then you say, well, you combine the document 1 and document 2. There are 3 legs there, one handle. Here there are 4 legs and one handle. You have taken the handle here and put it into a 4-leg chair. Therefore, your chair is, you think it's novel. Now, so somebody may come and say, but it's not, because see, chair with 3 legs and one hand is available. Chair with 4 legs is available. You only combine, but you are not allowed to do that for the purposes of novelty. For purpose of novelty, the essential features of your invention must be found either in one single document or in one common public source of information or product or whatever. That is the criteria of novelty. I will come to this criteria with some examples later on. The second one is the more difficult one to assess, is what is known as non-obviousness or inventive step. Now, what is it? So you will say, if it is an invention, it must have inventive step. So what is the new thing you're bringing in terms of law? Now, what the law says is, for an invention to satisfy the conditions of inventive step, or what is also known as non-obviousness, or invention must have a technological advance with respect to the existing state of publicly available knowledge that is not obvious. Mark these words, that is not obvious to a person skilled in the art without undue experimentation. What does this mean? Now, and the third criteria is it should be capable of industrial application, which means it must have some usefulness. But let's stick to the non-obviousness. The non-obviousness, it must have a technological advancement with regard to existing state of publicly available knowledge that is not obvious without undue experimentation, which means that there is a host of knowledge in the public domain. In one document, it says one thing. In another document, it says something else. In a third document, it says something else. In a fourth document, it says something else. Now, what have I done? I have studied document 1, document 2, document 3, document 4. I have realized that nobody has put these 4 documents together. I put them together. I create an invention out of that. Now, I will first argue a document that combines all this together. Therefore, my thing is novel. But on the other hand, if you look at it and say, if you combine this knowledge with that knowledge, with this knowledge, with that knowledge, which is available in the public domain, and you are a chemist, or you are a physicist, or you are a mechanical engineer, then in this particular area, if you read these 5 documents, you put it together, and if you are a person skilled in the art, so if it is related to mechanical engineering, a mechanical engineer. If it is related to food, then will be a food technologist or a food scientist, etc., etc. So, person skilled in the art would just be able to combine these, all this public domain information, and get your invention straight, or you will have to do a lot of experimentation to really arrive at your invention. That is called undue experimentation. If he has to do a lot of experiments, which means that all the data that was available in the public domain as you were doing your invention, okay, a person skilled in that art could combine. But then finally, when you combine knowledge, right, it may not lead to your invention, or it may not. So if the person may have to slightly tweak it and get to your invention. Now, if it is so, then your thing does not have an inventive step. If it is not so, then your thing has an inventive step. Now, I will carry on with a couple of examples to illustrate these points. And then we will have a now. So, what is available in the public domain? That is called the prior art. Whether it is a document, it's a product, or it's an information of any type, a newspaper report, whatever is available in the public domain, right? Accessible in the public domain. Then that is called prior art. Why is it called prior art? That is because the day on which you were filing your patent application, all this knowledge was in the public domain. So it's called prior art. Okay. That's the term, and you'll be hearing many a times this term called prior art. Now, let us go from here into an analysis of what is novelty, what is non-obviousness, and let's try and take a few examples to understand this concept. Because these 3 words, there is novelty, non-obviousness, and capable of industrial application, are these 3 criteria that will determine whether your invention will finally get a survived the attack from my filter number 1, which what were not inventions within the meaning of the act. You survived that, then you're subjected to these 3 criteria, these 3 benchmarks. You pass through these benchmarks, you get a patent. You don't pass through these benchmarks with any one of these, then you're not supposed to get a patent. Clear? Now, I'm not stopping
Sir,
here for
just
questions. Go ahead.
why is the third point necessary? I mean,
Yeah.
this.
Capable of industrial application, or that whether it is useful.
Yeah. So this
Because,
industrial application, why does it has to be industrial application? So
okay, when it says the
if
word
we do some,
capable of industrial application, that word industrial application is a very general term. It does not mean that you will set up a plant. Industrial application means that it should be scalable. That is not something that should be, you should be able to produce, you should be able to use it in a meaningful manner. It does not mean industrial scale operation.
Okay, sir.
Have I answered your question?
Yes, sir.
So the word industrial application does not mean that I have to set up an industry. Industrial application means whether what I have done, whether my invention has a certain application, and whether that invention, when it is applied, that you can actually use it in whatever where you are it is next. So, for example, suppose you are, you have created, let us say, a gear. Now, I create a gear, and those slots of the gear or whatever, I play around with those, and I come with an invention. Now, if you can't make gears which are going to be used for some application or the other, then what's the point? Simply doing something for the sake of doing, you don't get a patent. There has to be some application for it. Now that application, you may say, but that application is not available today. It will happen 10 years from today. So be it, but then you may have to justify. Clear?
Okay, sir. Yes, sir.
Yeah. So this is where now let us take a couple of examples. I will take some very simple examples to illustrate. So,
Sir, one doubt.
yeah,
Sir,
please go ahead.
so in prior art, you mentioned the prior art includes things that is captured in patents and literature of any form. So while filing patent, do we need to have extensive survey of prior art in literature also, not
Yes,
only the patents?
all, everywhere. So, in case of patent, what we do is we have to do not only search of patent literature, we have to do search of all literature, including newspaper reports and other things.
And those things can be,
If anything has been reported anywhere,
and can those things be cited, sir, while writing the patent? Other
okay, go
information.
ahead, please tell that again.
Anything that is not in the form of patent, can those things be cited while filing a patent?
Yes, you have to, because that's in the public domain. Because patent is also in the public domain. Please understand. I will show you maybe on Monday that you can search patent literature all over, and everything is in the public domain. Even patent literature, like your journals, is in the public domain. You can search.
Okay,
So,
sir.
so when we talk of prior art, we talk everything, not just journals, books, newspaper reports. We talk about everything and anything that's in the public domain. Even an advertisement pamphlet is a prior art as far as we are concerned. Any form of public disclosure is prior art. Clear?
Yes.
Sir, I have a question.
Please go ahead.
With non-obviousness that if I look at the example that we
Yes.
talked about in the earlier lectures, wherein we looked at the U-print. Now, a person who is into this business or people who are researching the safety bin or U-print,
Yes.
in a way, something may be obvious to them, but because it serves the purpose for now, people are not looking into something. And let's say I patent 10 different type of designs, 10 different variations of that same design, which are obvious, inventive in a way, but obvious to people who are into that domain. How to tackle this non-obviousness? I mean,
In
uh,
which case,
okay.
see, now it says, see the wording, publicly available knowledge that is not obvious to a person skilled in the art. It doesn't stop there. Without undue experimentation. That means simply by reading all that literature, whether in patent or otherwise, if you combine all that knowledge, it will bring you somewhere. Then I do a little thing here and there and I get where I'm going. But if that is not the case, like let me give you just a very quick example. Very quick example. Let us say that in front of you, I have a live big car. Let's assume for a moment, in front of you, I have placed before you a Honda City. So you are seeing that car. Now I tell you, please develop a Honda City 1/3 scale down from this car. I tell you the size. Make it 1/3 the size. Now, somebody may come and say, oh, so simple. Make everything 1/3. Okay? Then you will get a car of 1/3 the size. Is that correct?
Yes, sir. But things would not work at that scale down, the other components.
Absolutely. So you will get a car of that size. But that car will not work like the car which is of the large size. Why? Because now, because of the scaling down, the entire design of the gear may have to be changed. Otherwise, that gear will not work at that size. Maybe the transmission will have to be changed when you come down to the lower one. Otherwise, if you don't make the, redesign the transmission, the car will not work like the Honda City car. You scale everything down by 1/3, you will get the size. But will it work? So is it capable of industrial application? Answer is no. So
Okay.
simply scaling it down will not help. So a person skilled in the art, what will he have to do? He will have to that when I scale down, which are the parts by mere physically scaling down will not work. Then you have to go into the design. Once he goes into the design, then he'll go into the depth and say, oh, these gears have to be cut this way, this ought to be done this way, such and such ratios will have to be changed. How will you do all that? Not simply theoretically talking, but he will have to go through experimentation. That's the undue experimentation you will have to do to establish that this scaled down vehicle which has got, okay, is not only scaled down in size, but is also capable. You have to make it capable of industrial application. You have to change the gears, you have to change maybe the transmission, you have to change all that. Now, all those changes are not obvious. Otherwise, if anyone wanted to make a small car, he'll take a big car and just simply reduce it and make it. Does it happen? It doesn't. That is
Okay.
where the non-obviousness criteria comes in.
Thank you, sir.
Is it clear?
Yes, sir.
Okay. So we said that. So when you are doing your research and you are designing your experiments, you have to design it in such a way that with all the known literature, all the known knowledge, which I am combining from different sources, putting them together and creating my own, that creation is something where I have to show that that's a technical advance. So let me give you another example. Very, very interesting example. Okay. Um, for example, as far as you are concerned, right? Um, how many of you taken? How many of you are chemists in the group? Anybody who are chemists in the group? Is there any chemists in the group? Hello? Are there any chemists in the group? Or nobody is a chemist? Is anybody a chemist in the group or nobody is a chemist?
Very well. Just checking YouTube.
Is anybody in the group who is a chemist or not a chemist? Then I'll change the example. But reason I'm asking is that I'm going to give you
Not a
example.
chemist.
No, so people are,
Yeah.
there are no chemists in this group.
Yes,
I'm not a chemist.
Okay,
not a
nobody is a
chemist.
chemist. Okay,
Hmm.
so I will not take a chemistry example. I will take. Do we have anybody who's a who are engineers? What or physicists who are engineers? Are we having engineers?
Yes, sir.
Do we have any
Yes, sir.
chemical engineers?
There are quite a few engineers.
We have chemical engineers. Okay, mechanical and chemical engineers. Let us take some example from that. Otherwise, I would have taken a chemistry example. Let me take an example from mechanical engineering, and
There are
it is
YouTube
coupled.
questions. YouTube
Sorry?
questions. And there are question in the YouTube.
Yeah, please ask. Please ask.
It says it has two criteria of the novelty and inventive steps are satisfied, except application. Will that be invention? Will that invention get patent?
No, you will not get if any one of the criteria, if any one of the three criteria are not satisfied, you are not supposed to get a patent. Anyone. So if two are satisfied and the third is not satisfied, you are not supposed to get a patent. So any one criteria is not satisfied, then you will not get a patent.
Thank you.
That's the answer to the person who has asked in the YouTube. Any other? Can I proceed?
Yeah, you can proceed.
Okay. Okay. So now, all the chemical engineers in the group, mechanical engineers, and generally from the engineering and physics background. Now, if all of you have seen water flowing, correct? All of us have seen water flowing. Now, when you place some sort of an obstruction in front of flowing water, what do you observe generally? Certain type of obstructions in the front, in front of flowing water. So in the waterfront of flowing, I put, let us say, my fingers, in that stream. What do I generally observe?
Turbulence.
Turbulence. Now, with the turbulence, what else happens?
I get the force from the running water.
Turbulence is correct. With the turbulence, something else also happens.
Pressure drop in the flowing water.
Yes, and also what else happens? You're right.
breaks
All the
into
answers are right.
it
What
breaks
else?
into it breaks into two or more streams.
Right? That's the third thing. What else does happen?
Pumping cost increases.
Sorry?
Cost of pumping increases.
But also physically, what do you observe? Something you observe when you put certain type
Mixing.
of obstruction.
Mixing increases. Mixing in the fluid increases.
That of course happens, but there's something else also happens. Just think, see, right, flowing, something flowing, some fluid flowing, and you put a net in front. What happens at the other side of the net? Let's say I put a net, and the water is not flowing through the net. Then what happens at the other side of the net? Apart from turbulence, apart from everything you said,
It creates a bulge in that net.
yes, but equally important. Have you seen that bubbles get formed?
Yes.
Bubbles get formed. In chemical engineering, what do you call these bubbles? When these
Cavitation.
bubbles, sorry? So
Cavitation.
your cavitation. So you create these, so that you get into a process of cavitation, right? You produce these bubbles. You produce cavities in the fluid. You do cavitation, right? Now, when these things, this is a phenomenon which has been observed for a very, very long time, correct? You're flowing water, put obstruction in front, there will be bubbles which get formed, apart from other things. Then what happens to this bubble? What happens to the bubble?
It bursts.
Yes, yes. That bubble, after going a certain distance, burst. So when the bubble bursts, what happens? What in chemical engineering, the moment you create this cavitation, what have you done? What have you done in actual physics of it?
We have allowed the increase in heat and mass transfer, transport properties.
So you have one is you start locking certain amount of energy in that bubble, correct? So that when that bubble flows, and bursts, what happens? Energy gets released. So what happens? That they from here the bubbles were coming out, and when it came out somewhere here, it burst. It released the energy. That means you had this flowing. So when you take this part and the size of the bubble and the number of bubbles that will get formed will depend on the nature of the uh, obstruction that you put in front. Therefore, if you design that obstruction in a manner that you would like to, you will be able to control the number of bubbles in the side of the bubbles and also how far that bubble will travel and it will burst. Correct? And you can do a lot of theoretical modeling on this. And do a whole bunch of calculation of fluid dynamics and do everything, and you will get all this. Where you will bring in things like viscosity, the velocity of the flow, a whole bunch of other things out there. And then you'll be able to come with certain predictions on what will be the nature of the bubbles, what will be the size, how much of it, etc., etc. Right? We are going into analyzing all this. Let's assume that all knowledge is available in the literature. Whole bunch of knowledge on this. Now, tell me what sort of application of this you can think about. Is there any application to all this, which we just talked about at a very basic level?
Uh, One application that I can think of is when we are pumping concrete, so liquid concrete kind of to very high to heights. So any kind of blockage and kind of can lead to different type of cavitation. So I can think of its application there. So how to?
So the whole set of application will be that I can now control the energy dynamics. And depending on how much energy I need from the bursting of the bubbles, right? I can create the type of bubbles and the number of bubbles and where they will burst and how much will burst. And therefore, I'll be able to work out how much energy I need where to do something from these bursting bubbles. So where do you think people have applied something? Where do you think people have applied these concepts? Where you have this burst of energy,
The
you want to use
hydropower plant,
this burst of energy. Please go ahead.
hydropower plant.
No, not in hydropower plants. Not in hydropower.
Sir,
But this
fluidization.
energy is very local. This energy is only at the point where the bubble is.
Same fluidization operation.
Sorry?
In fluidization,
What operation?
fluid particle operations.
What particle operations?
Suppose we need to introduce heat into a particles. We will use
Yeah,
a sieve, and through that we will pass a liquid, and
yeah.
that will be distributed into small molecules and heat or mass can
Correct.
properly get transformed into those
So-
particles.
So you can do that, and if I wanted to carry out a chemical reaction at a very micro level, I can do these. And these bubbles will give me that burst of energy to overcome the activation energy. So I can do a whole bunch of types of chemical reactions. Number one. Somebody thought about it. His name is Anjan Mukherjee. He, he had come to me about almost 12, 13 years ago. He said, I have an idea. I want to use this cavitation for the purposes of, I will use this energy which is being burst from these bubbles. See, when you take groundwater, you pump the groundwater through a hand pump and get the water out. Water is full of microbes. So he said, look, without using electricity, without using anything, I will create a device where I will design these, baffles and obstructions so that when you hand pump and the water flows through that, it will create these type of bubbles. The bubbles will burst, they will release energy, and that energy should be sufficient to kill all the bacteria. Now, this he explained to me in my office. So I told him, how will you do it? So he had to design those baffles. He designed those. He created them. And he established the proof of based on that, designed a device. And that device, when you just retrofit it onto a hand pump, pump the water, you won't believe what happens. The water coming from the other side is free of microbes. So he created from this, we wrote the patent applications for him. He created a device out of that. He became an entrepreneur and he has made that and he's selling those devices in different parts of the country and now in different parts of the world to purify water, groundwater, without putting chemicals, without putting any other forms of energy, simply using cavitation as a technique. And if you're interested in seeing more details about this, the website where you can go to, he calls his company TARAL Taral TEC taraltech.com. His name is Ranjan Mukherjee. So here is a very ingenious application of the field of cavitation. So there's so much everybody knows. Now, is what he did is obvious or non-obvious? Question is, with all the literature put together out there, a person skilled in the art like a chemical engineer or a mechanical engineer, when they put all these things together, can they come to the exact configuration of his baffles, his invention, without doing undue experimentation? Our bone of contention is no, can't do that. So he has to do undue experimentation. Therefore, his thing becomes patentable. Now, what is people of industrial application? It will kill the bacteria from the flowing water. That is all scalable operation. You get my point? Have I explained it using this example? Any questions? Any questions?
No, sir,
No.
not right now.
It's clear to you from this example?
Yes, sir.
Give you one more
Yes.
example. Very interesting case. And he is a well-known doctor. In our session here, who is in Ahmedabad? Anybody in our session who comes from Ahmedabad?
Yes, sir.
Now, the name of the doctor in Apollo Hospital in Ahmedabad, his name is Dr. K.C. Mehta.
Yes, yes, yes. Ball.
Anyone of you? Sorry?
He treats knee replacements and
Absolutely. That's the man I'm talking about. He is a man who does knee replacement surgery, and every day he does about 5 to 6 knee replacements on a daily basis. So I sometimes make a joke with him saying that this rate in Ahmedabad, nobody is going to have a normal knee. So he does 5 to 6 knee operations every day. Okay? Knee replacement. Now, he very interestingly came to me a few years ago. He said, look, I have designed a new type of a knee. Now, when you do your knee replacement, you will find that in a the person who undergoes knee replacement can he move his leg. If this is a knee, then you can move his leg forward and backward like this. Can walk like that, but can't do this. Can't sit cross-legged. So if you have done a knee replacement, you can't sit cross-legged. You've done a knee replacement, leg to the other side out there. But see, the natural knee has got all the degrees of freedom, which the artificial knee does not have as of today. So he designed a knee which can do that. Now, when he designed that knee, he came to me. He said, look, I've designed this knee. So we studied that knee very thoroughly. And it turns out that the way he designed it, the complete shape, the configuration, the linkages of the knee, etc., all that, he did it in such a way, I mean, this part of the knee, and did it in such a way that you not only can do this, but you can also do this. And we filed a patent. He got the patent. We also filed that patent worldwide in various places of the world. And then finally, we want to get it commercialized. It's capable of industrial application. We then took his patent and sold it out to a company. That now you commercialize it. And obviously he got a bag full of money. I negotiated the whole deal for him. So you can see how you are thinking that now you may come and say there are hundreds of knee joints which people have designed. But the question is how by combining those 100 designs from 100 sources at the construction of his creation of his knee, all these properties, just straight. But then you have to do a lot of experimentation, do a lot of shaping, do this, do that, and only then you'll be able to get that. That's non-obvious. I made clear how you do. So therefore, if you are doing your experiments and you subsequently file patents for your work, then you will design your work not only to be new, also to overcome the issues of inventive step. Here, now if you go further, so the invention is not obvious to a person skilled without doing undue experimentation, should not be obvious extrapolating knowledge. So you have to demonstrate something unexpected. In case of Dr. Mehta, he demonstrated that his knee joint, what is the unexpected behavior of his knee joint? That it can do this. It can do this. almost like an almost, not completely, but almost like a natural ninja. So, including some unexpected advantages with regard to the existing knowledge in the public domain. So, suppose I will take an example from chemistry. Suppose I have two reactants, A and B, that produces C. Let's say it produces C in the presence of an acid, say hydrochloric acid. Now, if someone did an experiment later, not with hydrochloric acid, but say with sulfuric acid, A plus B going to C in the presence of sulfuric acid. Now, the experiment in the presence of citric acid, which is an organic acid, but nevertheless it's an acid. Then, if somebody did A plus B going to C in the presence of hydrochloric acid, and if somebody did A plus B going to C in the presence of sulfuric acid, then whoever did it with sulfuric acid, is his invention novel? If A plus B going to C in hydrochloric acid is in the public domain, he does A plus B going to C using sulfuric acid. So is his invention novel or not novel?
Not
Is
novel.
his invention novel or not novel?
Not novel.
Is it not novel or novel?
Not
How
novel.
many agree? How many agree that it is not novel? And how many agree that it is not it's novel?
So it says that the patent has been granted, so it has to be novel.
No, which patent has
So it is written that
he has done it with
acid.
he is applying for his patent. But then if he does it with sulfuric acid, somebody has done it with hydrochloric acid, it's novel or not novel? Are all the essential features of his invention available in the previous one?
It's novel but non-obvious.
No. Come to whether it is novel. It is novel. You said it's novel, right? Correct. It is novel. Why is it novel? Because
obvious.
all the essential features of invention are no. People have done it with hydrochloric acid. Now he's doing it with sulfuric acid. Therefore, when you go to the essential features of his invention, there's used sulfuric acid instead of hydrochloric acid. Therefore, his invention is novel. Now the question comes: does it have any inventor square? So, if the prior knowledge says carried out in hydrochloric acid, and he has done with sulfuric acid, novel, yes. Is it having an inventive step?
No,
Now answer that.
no, it's
Now
not.
you are saying no. Now why are you saying no? Let us understand.
Because similar material is used for the reaction.
Let's understand your reason. Let us understand the reason why you are saying that it is not obvious. Or somebody argues that see, that is hydrochloric acid, with sulfuric acid, it gives hydrogen ions, the
Yes,
pH come down, happens. So if you it's known in hydrochloric acid, what big deal if you have done it with sulfuric acid?
But
Somebody may
the
argue like that.
other product will be different. The
Which other product? Which other product? Is A
sulfide
plus B going to C? Is going to C. So
C
in
in the
sulfuric
case of
acid also A plus B will go to C.
I mean, the C in hydrochloric acid might be some chloride. The C in the sulfuric acid there is some sulfide, which must be having some other industrial application or some other usage.
No, that is a now. For example, suppose now let's argue that A plus B going to C in the presence of hydrochloric acid. Let us argument purpose, that my yield of that reaction, yield of C from A plus B going to C, let's say the yield was 80%. And obviously, therefore, there are certain impurities and whatnot. When he does it in yield went up from 80% to 90%. Now, would that be obvious to a person skilled in the art without doing the undue experimentation that if you're doing sulfuric acid, it will go up from 80 to 90?
No.
Necessarily. So he will come and argue, saying that no, it is not obvious. My inventive step is because I've been able to increase the yield. Yeah.
Yes.
The unexpected result. What is the unexpected result? And in this case, the yield went up. And therefore, you may provide hydrogen ions with sulfuric acid, hydrochloric acid. But when you provide the hydrogen ions in the presence of sulfuric acid, the yield goes up, which means it has got something to do with the anions which are present in the medium. Then it is not obvious. Before going for a patent, we have to do all these type of very, very detailed analysis of what is the technical advance that we are talking about. And then it becomes important for us that when we are doing our experiments, we have to design these experiments to illustrate these aspects so that my invention is not obvious to a person skilled in the art, and that my invention has as an inventive step, and that it is capable of industrial application. Now there are 5 minutes. So any questions from this, what I'm saying? Because after this, you have only one lecture on the 6th. I just want that before we that your understanding of so that you can design your research to meet the criteria of novelty, to meet the criteria of inventive step, to meet the criteria for capable of industrial application or being useful. Any questions on the YouTube? Any questions on the YouTube, please?
No, sir.
No, not so far.
Any questions on the people who are attending live?
One
Please.
question to you.
Please.
In this example, A plus B, I'm going to see how can it be novel, sir? It is an extension only.
How come it is normal? Because A plus B going to C was there in the public domain. Is there in some paper, let us assume in some journal. Let's also assume that A plus B reacting in the presence of hydrochloric acid is also in the journal. Now, I do the reaction A plus B going to C in the presence of sulfuric acid. So my argument is sulfuric acid is not hydrochloric acid, though both are acids. That's why one is called sulfuric acid, the other is called hydrochloric. Therefore, if you look at the essential features of the invention, then is A, B, hydrochloric acid, and C. And what I have done is A, B, sulfuric acid, and C. the hydrochloric acid different from sulfuric acid, therefore my thing is novel. However, what you may say, but it is an acid. But I'm saying, look, it may be an acid, but in my case it's sulfuric acid. In his case it is hydrochloric acid. So it's an acid. The criteria that you will challenge him is that is it hydrochloric sulfuric acid? But if I show you that by using sulfuric acid, I get less impurities, I get higher yield. Clearly, I have an inventive step which you could not predict by using only hydrochloric acid. That using sulfuric acid, you will get this something result of that. Have I answered?
Yeah, it's a into question. I think he must be hearing.
Yeah, that is how it is. So what we have done, it's now 5 o'clock. So what we did today is we looked at just as a quick summary. What did we do today? We looked at the filter number 2. So from filter number 1, we went to filter number 2, and we looked at the details of filter number 2. And it's so important, therefore, that when we are designing our whichever, maybe physics, maybe biotechnology, whatever, we have to understand the literature, that literature being the holistic literature, right from journals, books, patents, etc., etc. Then come and say, this is what is the total literature, and this is the way I want to do my experiments. Therefore, I will design my experiments this way to meet the criteria of inventive step, and to meet the criteria of novelty, and to meet the criteria of being capable of industrial application. Clear? You can see that when you come to do patenting, we ask you lot many more questions than when you just want to publish. The patent attorneys will really ask you lots and lots of questions. And you will have to have the patience to answer each and every one of those questions. Yeah. So this is where we will stop our lecture today on this, and we come back. So I will just stop sharing and get back into this screen. So what we did today, look at the filter number, and therefore what we have learned is that when we want to design our experiments, we will design those experiments in such a way that we will be able to overcome the objections of the of this requirement. Clear, right? Should we log out?
Yes.
Yes, sir.
Okay. So we will log out, and now we will meet on the 6th afternoon.
Yeah. Sir, I have a stupid
Okay.
question.
Thank you. Thank you.
One is related.
He went.
Hello? For next time. We give him a quiz. Look, I think they're not sorry, they're not gonna